hydrogen plasma, a type of nuclear matter composed by free quarks and gluons. We only can find it inside a neutron star, and yes, microseconds after the Big Bang, with temperatures of 135 megalecton volts. Such conditions try to be recreated in experiments like ALICE at CERN. But before to understand it, we have to understand the theories that describe the interaction between the particles, the quantum chromodynamics. The QCD is a non-abelian quantum field theory that describes the strong interaction between particles known as quarks. These are confined in other particles, like baryons, formed by three quarks, such as proton and a neutron, and in mesons, formed by an antiquark-quark pair. Like all quantum field theory, we have particles and charge, colored charge in this case, red, green, and blue, with their respective anticharge. In the nature, we only find total neutral charge, because just as in the light, the mixture of colors give white, in QCD the mixture of charge produces a neutral charge, so in QCD the color is conserved. This concept was introduced in 1973 by Fritsch, Liguorier, and Gell-Mann to respect the Pauli exclusion principle, which tells us that we cannot have two fermions with all their quantum numbers equal. Now, the particle that mediates this force is the gluon, a boson of mass 0 and spin 1. There are 8 different types of gluons. 6 change their charge, and 2 retain it. We have 8 gluons because when we combine the charge, the non-zero possibilities are only 8. The strong force is very similar to having a rubber. For example, each finger will be a quark. If we try to move them away, it becomes more and more difficult. On the other hand, if we put them together, the force becomes weaker and weaker, and the quarks seem to be almost free. That is known as asymptotic freedom. Understanding this also helps us to estimate the mass of particles. For example, the only 5% of the mass of a proton corresponds to its interaction between the Higgs field. The remaining percentage corresponds to the energy of the strong interaction between the quarks inside the proton. So, remember the Einstein equations, this energy can be expressed in terms of mass. The QCD also talks about interesting things, like globules, or particles formed by more of three quarks, like multiquarks, or the strange-shaped problem, or the interaction between protons and neutrons through a pion. Well, I hope that you had fun learning about QCD, and that you have many questions for Q learning. Thanks for watching, and that was a video for Pikachu Learning Challenge.